Welcome to JMR classes. Today we are going to learn interesting part of the circles. Grade 9, session 4. Today we are going to concentrate most of the numericals. A chord of a circle is equal to the radius of a circle. Then find the angle subtended by the chord at any point on the minor arc and also at a point on the major arc. How can we find? First of all, let us try to draw the diagram. Here, PQ is the chord. OP, OQ are the radii. This PQ length is equal to OP length. Therefore, triangle OPQ is an equilateral triangle. Therefore, PQ is equal to OP is equal to OQ. Since it is an equilateral triangle, all the three angles are equal. That means angle POQ is equal to angle OPQ is equal to angle OQP is equal to 60 degrees. But he asked us to find the angle subtended by the chord at a point on the minor arc. So that means we need to find angle PBQ. And also we need to find angle at A, that is angle PAQ. How can we find these two? First of all, let us find angle PAQ. Why? Because angle POQ is equal to 2 times angle PAQ. Why? The angle subtended by an arc at the center is double to the angle subtended by the same arc at the circumference. Therefore, angle POQ already we know 60 degrees. Therefore, 60 degrees is equal to 2 times angle PAQ. Therefore, angle PAQ is half of the 60 degrees. That is nothing but 30 degrees. As soon as we got angle PAQ is 30 degrees, let us observe the quadrilateral APBQ. The quadrilateral APBQ is cyclic. Why? Because all the vertices lying on the circle. Therefore, sum of the opposite angles is 180 degrees. Therefore, angle PBQ plus angle PAQ is equal to 180 degrees. Therefore, angle PBQ is equal to 180 minus 30, that is equal to 150 degrees. Hence, we find the required things. That's all. Have you understood? I hope you all enjoyed this problem and you find it very easy. Let us go to the little more tricky problem. Let us go further. In the given figure, there are two congruent circles with the centers O and O dash. They are intersecting at A and B. If angle AO dash B is 50 degrees, if this angle is 50 degrees, we have to find angle APB. Angle APB. How can we find this? Let us see. They are congruent circles means equal radii circles. Equal radii circles means let us observe. OA is equal to O dash B. OB is equal to O dash A. Because all are equal radii. Equal radii. Therefore, angle AOB O dash is a rhombus. If it is a rhombus, opposite angles are equal. Therefore, angle AOB is 50 degrees. As soon as we got angle AOB is 50 degrees, there is a theorem, angle subtended by an arc at the center is double to the angle subtended by the same arc at the circumference. So, since angle AOB is 50 degrees, we can find angle APB. Why? Because angle AOB is equal to twice angle APB. Therefore, angle APB is half of the angle AOB, half of 50 degrees. which is nothing but 25 degrees. So angle APB is 25 degrees. This is also very easy problem. Let us go through it, and I hope you can solve this problem without seeing. Now let us go to the third problem. In this diagram, find X. Here ABCP is a cyclic quadrilateral. CBD is an exterior angle. AOC is the angle made by an arc at the center. So how to solve this? I want to find the value of X. Angle CBD plus angle ABC is equal to 180 degrees. Why? Yes, you are correct. It is linear pair. And angle ABCP is a cyclic quadrilateral. Therefore, sum of the opposite angles is also 180 degrees. That means angle APC plus angle ABC is equal to 180 degrees. Since both equations 1 and 2 are equating to 180 degrees, equate them. Equate their LHS. So, angle CBD plus angle ABC is equal to angle APC plus angle ABC. Angle ABC gets cancelled. Angle CBD is equal to angle APC. Angle CBD is equal to angle APC. Therefore, I need to find angle APC now. What is angle APC? Angle made by an arc at the center is double to the angle made by the same arc at the circumference. Therefore, angle AOC is equal to twice that of angle APC. What is angle AOC? He has given 120 degrees. So 120 is equal to 2 times of angle APC. Therefore, angle APC is equal to half of the 120, which is nothing but 60 degrees. As angle APC is 60 degrees, you can find angle CBD is also 60 degrees. That means the exterior angle is equal to 60 degrees. From this, we can conclude one interesting fact. The exterior angle of a cyclic quadrilateral is equal to opposite interior angle. I hope you all enjoyed this problem. Let us go further. Let us do one more problem. If O is the center of the circle, find X. Here, OA and OE are the radii of the circle. Therefore, triangle OEA is isosceles triangle. Isosceles triangle will have two equal angles. Therefore, angle OEA is 35 degrees means angle OAE is also 35 degrees. Now, apply angle sum property of the triangle OEA. How much? How? Let us see. Angle OEA plus angle OAE plus angle AOE is equal to 180 degrees. 35 plus 35 plus angle AOE is equal to 180 degrees. Therefore, angle AOE is equal to 180 minus 70, which is nothing but 110 degrees. As soon as I got angle AOE is 110 degrees, angle AOE is the angle made by the arc ACE at the center. Now, take any point on the major arc. Let us take F. Construct an angle AFE. Now, this angle AOE is twice that of AFE. Why? Because angle made by an arc at the center is double to the angle made by the same arc at the circumference. Therefore, angle AOE is equal to angle AFE. 110 is equal to angle AFE. Angle AFE is equal to 55 degree. As soon as you got angle AFE is 55 degree, you can find angle X very easily. Why? Because AFEC is a cyclic quadrilateral. In a cyclic quadrilateral, opposite angles are supplementary. Therefore, 55 plus X is equal to 180 degrees. Therefore, X is equal to 180 minus 55, which is nothing but 125 degrees. I hope you all understood this problem. It is easy problem, but little tricky. Next problem. In the figure, angle PQR is 100 degrees, where P, Q and R are the points on a circle with the center O. Find angle OPR. How can we find? Let us see. Join OR. Then we got an isosceles triangle OPR. OP is equal to OR. Why? Because the radii of the same circle. That means angle OPR is equal to angle ORP. Angles opposite to the equal sides of isosceles triangle. Let us assume that angle is X. So that means in triangle POR, angle OPR plus angle ORP plus angle POR is equal to 180 degrees. X plus angle POR is equal to 180 degrees. 2x plus angle POR is equal to 180 degrees. Angle POR is equal to 180 minus 2x. Up to here clear? Let us take a point S on the circumference and construct an angle PSR. Now angle PSR is equal to half of the angle POR. That means angle POR is equal to twice angle PSR. Therefore, I can find angle PSR as half of the angle POR, that is equal to 180 minus 2x by 2, which is nothing but 90 minus x. Angle PSR is 90 minus x. PSRQ is a cyclic quadrilateral. Therefore, sum of their opposite angles is 180 degrees. Therefore, angle PQR 100 plus angle PSR 90 minus x is equal to 180 degrees. Using this, we can find very easily the x value. 190 minus x is equal to 180. So therefore, x is equal to 190 minus 180. X is equal to 10 degrees. Therefore, angle OPR is 10 degrees. I hope you all understood this problem. It is very easy problem. Let us go further. Let us learn an interesting theorem. Angles in the same segment of a circle are equal. That means what? Let us see. There is a circle. There is a segment AB. In this segment, this is the minor segment, and the segment which contained center is a major segment. Now angles in the same segment. I have taken an angle ACB in the major segment, and another angle ADB is also in the major segment. Now what is my task is, I have to prove angle ACB is equal to angle ADB. How can I prove? The proof is very simple. Join OA and OB. Join OA and OB. What is angle AOB? Angle AOB is the central angle. Angle made by an arc AB at the center. Now, angle ACB is nothing but half of the angle AOB, or angle AOB is twice angle ACB. Similarly, angle ADB is also twice angle AOB is also twice angle ADB. Therefore, by equating the RHS sides, 2 gets cancelled. Angle ACB is equal to angle ADB. That means angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. Now, let us do another interesting problem. Angle ACB is 31 degrees. Angle ABC is 69 degrees. Find angle BDC. How can we find? Very simple. Take triangle ABC. In the triangle ABC, we know the two angles, we have to find the third angle. We can use angle sum property and we can find angle BAC. But the question is asking us to find angle BDC. We know from the previous theorem, angle BDC is nothing but angle BAC. Why? Because angles in the same segment are equal. So now let us find BAC. That will be automatically equal to angle BDC. How can we find angle BAC? Angle BAC plus angle ABC plus angle BCA is equal to 180 degrees. Angle sum property of a triangle. Therefore, angle BAC plus 69 plus 31 is equal to 180. Angle BAC is equal to 180 minus 100 degree. That means angle BAC is 80 degrees. As soon as we got angle BAC is 80 degrees, you can conclude that angle BDC is also 80 degrees. How simple it is. It's a very easy problem, isn't it? Let us go further. Let us do another problem. In the figure, A, B, C, and D are the 4 points on a circle. AC and BD intersect at point E such that angle BEC is 130 degrees and angle ECD is 20 degrees. Find angle BAC. How can we find angle BAC? See, angle BAC is equal to angle BDC. Why? Because angles in the same segment are equal. Now, let us see. Angle BAC plus angle CED is equal to 180 degrees. Why? Linear pair. So 130 plus angle CED is equal to 180 degrees. So angle CED is equal to 50 degrees. Up to here clear? As soon as we got angle CED is 50 degrees, we can find the missing angle BDC. How can we find? By applying angle sum property. Angle ECD plus angle CED plus angle EDC is equal to 180 degrees. 20 plus 50 plus angle EDC is equal to 180 degrees. Angle EDC is equal to 180 minus 70, that is equal to 110 degrees. If you got EDC is 110 degrees, that is nothing but angle BDC only. So angle BDC is also 110 degrees. As soon as you got angle BDC 110 degrees, you can claim that angle BAC is also 110 degrees. That's what we have to find. I hope you all understood this problem. Very systematic and easy, step-by-step procedure. Good. Let us go further. ABCD is a cyclic quadrilateral whose diagonals intersect at point E. If angle DBC is 70 degrees and angle BAC is 30 degrees, find angle BCD. Further, if AB is equal to BC, find angle ECD. How can we do this? He has given that ABCD is a cyclic quadrilateral. Diagonals are intersecting at point E and DBC is 70 degrees and BAC is 30 degrees. And we have to find BCD. How can we find? If AB is equal to BC, then find ECD. These are the questions. Let us see. Think for a while and how to solve. So, angle BDC is also 30 degrees. Why it is 30 degrees? Can you guess? Since angle BAC is 30 degrees, angles in the same segment are equal. Angle BDC is also 30 degrees. Up to here clear? Now, in the triangle DBC, apply angle sum property. Angle BDC plus angle DBC plus angle BCD is equal to 180 degrees. Therefore, 30 degrees plus 70 degrees plus angle BCD is equal to 180 degrees. Angle BCD is equal to 180 minus 100. Angle BCD is equal to 80 degrees. It is very, very simple. Then you have to find angle ECD. How can you find angle ECD? For that purpose, he has given that AB is equal to BC. If AB is equal to BC, then ABC will become an isosceles triangle. If ABC is an isosceles triangle, equal angles are equal, base angles are equal. That means angle BAC is equal to angle BCA, which is equal to 30 degrees. Angles opposite to the equal sides of an isosceles triangle are equal. Therefore, angle BCE is equal to 30 degrees. As soon as when we got angle BCE is 30 degrees, angle ECD, how can we find? Yes, 80 minus 30, that is 50 degrees. Of course, this problem is a little tricky, but very easy. Follow systematically. I hope you all enjoyed this problem. Let us go further. Let us do one more problem. Two circles intersects at the point B and C. Through B, two line segments ABD and PBQ are drawn to intersect the circles at AD and PQ respectively. Prove that angle ACP is equal to angle QCD. Now let us observe carefully. Angle ACP is equal to angle ABP. Why? Because angles in the same segment are equal. Similarly, angle QCD is equal to angle QBD. The reason is same. Angles in the same segment are equal. Now, if we have observed carefully, the line AD and a line PQ are intersecting at B. Therefore, there are two vertically opposite angles have been formed. Those two vertically opposite angles are angle ABP and angle QBD. As these two vertically opposite angles are equal, name it as equation 3. Observe equation 1, 2 and 3. Angle ABP is equal to QBD, but angle ABP is already equal to angle ACP. Therefore, angle ACP is equal to angle QBD, but angle QBD is equal to angle QCD. From these three equations, I can conclude that angle ACP is equal to angle QCD. That's what he asked. How easy it is. Very interesting problem, you know, and very simple. Though figure looks complicated, but it is very easy. Now, let us see one more interesting problem. Triangle ABC and triangle ADC are two right angle triangles with common hypotenuse AC. Prove that angle CAD is equal to angle CBD. How can we prove this? Let us take the quadrilateral ABCD. In that quadrilateral ABCD, angle B and angle D are 90 each. That means these two are opposite angles. These two opposite angles sum is 180 degrees. Therefore, I can conclude that ABCD is a cyclic quadrilateral. When ABCD is a cyclic quadrilateral, I can draw a circle passing through A, B, C, D. Now, observe the major segment DABC. When you are observing the major segment DABC, in that angle DAC is equal to angle DBC. That means angle CAD is equal to angle CBD. Why? They are the angles in the same segment. Hence proved. The problem is very simple. The problem over. What we required, we have already proved. It is very simple. Identifying a cyclic quadrilateral, identifying two angles are equal. Is it clear, dear friends? I hope you all enjoyed this session. Let us meet in the next session. See you.